You just spent 6 hours editing the perfect video. You click export and CapCut holds your content hostage behind a paywall. Put your wallet away, meet OpenCut.
This chart compares CapCut's proprietary market dominance against the open-source adoption of OpenCut, with over 64,000 stars and 7,000 forks on GitHub. Developers are clearly searching for an alternative to a paywall video editors. No data harvesting, just a ridiculously fast, privacy-first video editor being built to replace CapCut entirely. It might be time to uninstall.
OpenCut operates as a free, local-first, non-linear editor. It completely removes telemetry, data harvesting, and the feature restrictions typical of commercial software. The classic web version proved this model works, offering a multi-track timeline and basic effect layering directly in the browser. But browsers have strict memory and compute limits. A web-only tool cannot replace a native professional editor in high-end, hardware-intensive video workflows. To bypass those strict browser limitations, the OpenCut team is executing a massive, ground-up rewrite of the entire architecture. The design objective for the rewrite is to establish a shared codebase that can eventually deploy to the web, desktop, and mobile devices simultaneously. Moving away from Electron wrappers and web-only execution to a true native engine provides direct access to system hardware. This is a strict requirement for professional-grade video rendering and real-time acceleration. By completely rebuilding the engine, OpenCut allows the editor to function as a programmable platform rather than a static web tool. This maps the new OpenCut monorepo. It uses moonrepo as an orchestrator to manage 3 distinct technology stacks in parallel: the API, the web client, and the desktop application. At the root level, the workspace is governed by a configuration file called .prototools. This file pins the exact toolchain versions. Every developer and continuous integration machine across the project automatically uses the precise designated versions of Rust and Bun. Beside it, bunfig.toml manages package resolution and enforces minimum release age limits for all web dependencies. This strict orchestration layer eliminates works on my machine errors. Global contributors can safely write and test code across vastly different technology stacks at the same time. If you assume a modern React video editor defaults to Next.js, looking inside the webpackage.json reveals a different approach. The actual front-end architecture is built on TanStack Start combined with Vite. The editor interface relies on Tailwind CSS, integrating shadcn and base UI components to construct the complex timeline and tool panels. This deployment pipeline shows how both the TanStack frontend and the separate API layer are routed directly through Cloudflare workers out to the edge network. Within that backend, the team uses Elysia to handle rapid routing and enforce strict type validation. Running this on Cloudflare workers guarantees low-latency access globally for the web client, entirely bypassing the need to manage traditional server infrastructure. This stack explicitly prioritizes edge-native deployment and pipes compilation speeds over heavier server-side rendering frameworks. The most critical engineering shift is located in the desktop directory, where OpenCut implements its Rust language core. Instead of pushing pixels through a heavy browser DOM, OpenCut uses GPUI, the framework behind the Z code editor, to communicate directly with the system hardware. macOS leverages Metal, while Linux gets the same benefit through a dedicated Vulkan pathway. On Windows, the engine utilizes DirectWrite and Win32, guaranteeing native performance across all operating systems without requiring bloated extra dependencies. Because the underlying logic is written entirely in Rust, this exact same rendering engine will eventually power the mobile applications. Adopting the GPUI framework provides the high performance ceiling OpenCut requires to execute complex video rendering tasks as efficiently as proprietary industry standard video editors. The new architecture introduces a concept called programmable video engineering, which is driven by an upcoming dedicated editor API. This includes a headless mode, allowing automated batch rendering scripts to process video files in the background without ever spinning up a graphical interface. To interact with AI tools, the core incorporates a Model Context Protocol, or MCP, server. This flowchart illustrates how the MCP server operates. An external AI agent can send text-based instructions through the server, which then sequentially translates those prompts into programmatic razor cuts and edits directly on the timeline. Setting up this environment locally is straightforward. Running proto-use in the terminal fetches the precise pinned toolchains. From there, executing moon-run web:dev launches the front-end localhost environment. For the native client, moon-run desktop:build compiles the Rust core. This first desktop build takes time, as it must compile the entire GPUI source library from scratch. These automation features and simplified local builds provide the technical baseline required to construct automated AI video pipelines. However, if you pull the rewrite branch today, you need to set your expectations. As this mockup clearly shows, while the classic web version on the left remains a fully functional multi-track video editor, the native desktop rewrite on the right is in its absolute infancy. It currently functions as little more than a basic rendering window. Because the core API architecture is still actively being designed, outside community contributions are temporarily paused. When compared directly to a mature commercial tool like CapCut, OpenCut lacks the pre-built social media templates and AI generation effects that everyday creators rely on. Users who need a production-ready, template-heavy tool today should stick to OpenCut Classic or proprietary software. The rewrite is a long-term engineering investment. That investment is pointed toward a very specific endpoint, establishing an open-source, programmable video engine. Developers, automation engineers, and privacy advocates should closely monitor this Rust-backed ecosystem as the core nears completion. The planned first-class plugin architecture will allow the open-source community to rapidly build out missing features and close the gap with commercial editors. Test the classic web app right now, or audit the new monorepo architecture directly on GitHub.
Here is my final verdict. OpenCut is the most promising open-source video editor I've ever seen. Batch rendering and an in-editor scripting tab coming soon, it's going to be a powerhouse. Have you tried it yet? Let me know in the comments below. And hit subscribe for more open-source gems.